Okay, good afternoon, everybody. I hope everybody is doing well. I'm just going to start off by taking you to the Google Classroom where I posted the answer key to the balancing equations worksheet and the voyage through equations worksheet, as well as the single displacement and double displacement reaction worksheet. So I signed all of these last Friday after, if you look down here, after my lesson on types of reactions. And then I also did balancing reactions in the Zoom meeting, the lesson in there. Okay, and the worksheet for balancing equations is right here. Okay, so make sure you're checking Google Classroom regularly and watching all the lessons because they could help you in completing the worksheets. Okay, so the next Zoom meeting is tomorrow morning at 11:30 a.m. So I hope to see you all there if you have any questions. And remember, midterm marks are due on Friday. Okay, so we're going to start off by taking up the single displacement worksheet because that's where we ended off last lesson. So I talked about the activity series list, and I said that depending on your activity series list from this note here, it can tell you which metal will displace another metal. So let's just recap that right here. Okay, so here's your activity series list. It's given on your single displacement sheet, and you can predict whether aluminum will kick out calcium based on where it is on the list. So if aluminum is above calcium, which in this case it is not, so it cannot happen. So that's why it says no reaction here. Okay, so we're going to take up that worksheet now, right here. Okay, so here's the worksheet, and I'm just going to go over the answers. Okay, so right here, the first one is aluminum plus calcium chloride. This was given in the PowerPoint. So aluminum, if you look at you have to refer to the activity series list on the page right before it. So this is the back of the page. So you'll find that aluminum is below calcium on the list. So therefore it cannot kick it out. So that's why we wrote no reaction. Here, aluminum is in fact above iron, so it can kick it out and the reaction proceeds. So when it does proceed, you have to predict the products. So what's left is iron, and aluminum is going to combine with oxygen. So you have to to find out the products, you have to do crisscross first. So you have to figure out that aluminum is +3, oxygen is -2, and then you crisscross to get Al2O3. Fe remains like on its own, like as a single element, and then you balance the whole equation after you figured out the products. Okay, for this one, zinc is not above magnesium. Magnesium is in fact above zinc. So therefore zinc is not stronger than magnesium to kick it out. Okay, so therefore there's no reaction. Okay, so next is activity series list for halogens. So the halogens list is pretty small. Here they're asking you, is I2 stronger than Cl to kick it out? Is I above Cl on the list? And it is not, so therefore no reaction. Is Cl higher than Br to kick it out? And it is on the list, so therefore it will happen. So how do you predict the products? Cl is going to kick Br out, so Br is going to be on its own, but remember Br exists in twos because it's part of the Hofbrinkel. And Na combines with Cl, and you have to do crisscross rule to figure out what it becomes, so it's NaCl, and then you balance the equation. Okay, next one, Mg plus 2HCl. So you want to see, is magnesium higher than hydrogen on the activity series list? And in fact it is, so you figure out the products, MgCl2 plus H2. NaCl plus Ag is Na above silver, and it is not, or sorry, is silver above sodium to kick it out. And it is not, so therefore no reaction. So yeah, you just want to keep going with that, and these are the answers here. So if you have any questions about single displacement reactions, please reach out and let me know. Okay, so we're going to move on to today's lesson, which is double displacement reactions and precipitation reactions. So we're going to see how do you figure out whether a solid or precipitate is formed today. So this is our lesson for today. So we're going to predict and write equations for precipitation reactions. We are not doing this right here, okay? So we're taking that out. Double displacement reactions occurs when ions exchange between two compounds, so you get a double swap. So an example right here, Ki plus PbNO32, there's literally a double swap. So the K combines with NO3 and the Pb combines with I, and you get two new compounds in your products. And notice PbI2 is a solid and KNO3 is aqueous. So today we're going to figure out how do we figure out if there's a solid formed, because that determines whether a double displacement reaction happens. If there are no solids formed, then you say no reaction. If they are both aqueous, no reaction. Okay, so in this picture here, it shows you a precipitate or solid forming. That's the yellow clump here is PbI2. Okay, so here's an example of something that makes no reaction. There's no solid formed. Okay, so Ki plus NaCl, you get NaI plus KCl, which are both aqueous. Okay, so this is just saying that the solutions, when you mix them, they break up into their ions, and then they recreate new products. Okay, so it's just kind of explaining the molecular part of that. Okay, so here is an example. So Na2CO3 plus CuCl2. So this is your first question that's on your double displacement worksheet. Na2CO3, so the outsides go together. So Na is going to combine with Cl. So we treat elements as individual. We don't look at the numbers, okay? Cu is going to combine with CO3. So you do crisscross rule from the beginning. Na is +1, Cl is -1, and you crisscross and you get NaCl. Cu is +2, CO3 is -2. When you crisscross, you get CuCO3. Okay, so out of these two products, which one will be a solid, or both of them might be aqueous? So how do we figure out which one is the solid? So we look at this chart that's on your double displacement sheet. Okay, you do not have to memorize what's going to make a solid. Okay, so for example, in this one, NaCl, that's sodium chloride. So we're going to look and see that all chlorides and other halides are very soluble, except when they're paired with these ions here, which is not Na. So one rule you should memorize is sodium, potassium, and ammonium salts. So NaK+ and NH4, whenever they're combined with anything, they're always very soluble. Okay, so that's why they said there's no exceptions here. So NaCl is aqueous. Whoops. Yeah, so NaCl will be aqueous. This one though, carbonate, let's look at the chart. Let's go to carbonate. Okay, so slightly soluble means it's insoluble. Okay, so it forms a precipitate, so it becomes a solid. So CO3, -2, any carbonate, it says it will form a precipitate except with group 1 ions. Group 1 is sodium, lithium, potassium, and all that, and ammonium. Those are always soluble. Okay, so basically all carbonates are insoluble. They form a solid. So that answers our question here. So this will be a solid. So you're going to put S beside it. Okay? So that's your answer to your first question on your worksheet. Okay, so this is your answer here. You put solid here, aqueous here. Okay, do you guys see that? So I'm just going to point this means precipitate. Okay, PR means precipitate. Okay, so hopefully you guys kind kind of see that. So the last step is balancing the equation. So once you figured out what is the solid, what is aqueous, and remember, if they're both aqueous, then you'd write no reaction. Okay, but if you have a solid, the next step is to balance it. So this is balanced here when you put a 2 in front of the NaCl. Okay, so let's practice. Let's combine KNO3 and BaCl2. Okay, so I want you to try this on your own. You can pause the video if you want, and then check your answer. So K is going to combine with Cl. Remember, you want to ignore any subscripts. You're basically trying to figure out what's going to go with what in the product. So outsides go together, insides go together. So K is going to combine with Cl. Ba is going to combine with NO3. So you're going to do the crisscross rule to figure out your products. So K is +1, Cl is -1. You crisscross, you get KCl. Ba is +2, NO3 is -1. So you get BaNO3 brackets 2. Okay. Okay, so that's the end of that slideshow. So I'm just going to take you to the worksheet and we're going to take it up. Okay, so here is the same question we went over in the PowerPoint right here. That's number 1 of your worksheet. Okay, and then these are the solutions to the other ones that we just looked at in the PowerPoint. Okay, so when K combines with Cl, it becomes KCl. And remember, all potassium, sodium, ammonium salts, and all alkali metals, they're always soluble. Okay, whenever you have nitrates as well, they're always soluble. So NO3 is soluble. So because they're both aqueous, this is no reaction. Okay, so try the next one, see if you understand how you got the products. And remember, if you get one solid, in this case, hydroxides are always solids, you do have to balance it as the last step. Okay, so that's it for today. I do want you to work through these because it will be on the quiz on Friday. We're going to be doing a small quiz to test this week's work. Okay, so have a great day.